Hello. In today's class, we'll be going further with the lesson, that is, we'll be doing about potentiometer. It is a device used to find potential difference between 2 points. Used to find potential difference between 2 points. Okay. So now let us consider a cell connected to the terminals of a wire AB. This wire AB is of length L. Now, supposing the potential of this battery is V, that means what? The positive side has V potential and the end connected to the negative side is 0 potential. Okay. So if the total length of the potentiometer of the wire is L, at one end we have V and at the other end we have 0 potential, then current flows from A to B. That is our knowledge till now. Okay. Supposing I ask, what is the potential halfway through the wire? What will you say? The potential halfway through the wire will be nothing but V by 2, because as we proceed further along this wire, the potential goes on decreasing and finally becomes 0 here. That is a theory. So here halfway through it is V by 2. So that means there is a drop in potential. When we go towards the 0 end, towards the B end, there is a drop in potential. So when we go 1 millimeter towards the B end, how much will be the drop? So here, supposing this length is 1 meter, 100 centimeters, okay, let it be 1000 millimeters, then the drop in potential per millimeter. The drop in potential per millimeter. See, for the whole length L, we are getting potential drop to be V. V minus 0 is V. So here, the drop per millimeter is V by 1000, because here L is equal to 1000 millimeters. Okay. So supposing we have a 1.5 volt battery. So how much is the potential drop here? Okay, 3 volts battery, 2 cells are there, I'll keep a 3 volts battery. So the potential drop will be 3 by 1000, that's equal to 0.003 volts per millimeter. Volts per millimeter. This much will be the potential drop per millimeter. This potential drop per millimeter, let us represent it as V by L. This V by L is called the potential gradient. Now what is a gradient? For example, supposing we have V on the y-axis and L on the x-axis. When V is maximum, that means L is 0. So as L is increasing, for the maximum length L, the potential becomes 0. So how will you get your graph? We will get our graph something like this. So here the drop is there gradually, and here supposing we have V by 2, this will be V by 2. Okay, at half of the length. So this is how this slope here like this is called the gradient, and hence this V by L is the drop in potential per millimeter. So 1111 millimeter when we go, this potential will be dropping along this line and finally coming to 0. So this is called potential gradient. Okay. Now, ultimately this potentiometer is used to find the potential difference. So I want definitely when I am using it to find the potential difference, I want accuracy in my values. So how do I increase the accuracy? Simple it is. The accuracy can be increased by either increasing the voltage, okay, either increasing the voltage if this is decreasing the voltage, because lesser the potential gradient. So as we go 1 millimeter, if the drop is less, supposing the drop is by 1 volt or the drop is by 0.1 volt, which one is more accurate? The drop which is by 0.1 volt is more accurate. So here, when V by L is 0.1 or V by L is 1, which one is more accurate? V by L is 0.1. That is more accurate. That means the potential gradient, as small as it is, that much sensitive and that much accurate our instrument also will be. So here V should be decreased or L should be increased. V should be decreased means here we are already fixing this battery, or we can even add a variable battery so that a battery eliminator, and we can decrease, fine. But the better way is to increase the length. Here I have taken only 1 meter, but supposing I take 5 meters length or 4 meters length, so I take V by 4000 millimeters. This one will be more accurate than V by 1000. Now why I took 4000 is because in our lab we have 4000 millimeters potentiometer. Okay, just imagine when we have a 4 meter table, when we have a large table and we are stretching 4 meter wire, 5 meter wire, it will be difficult. So how it is made is this, there is a big wooden box like this, and again connecting strips will be there like this, and supposing this point is point A, this side also connecting strips will be there. Okay, this point is point A and it is wound around inside this connecting strip, and it comes like this, and it goes like this into this, and goes like this here, and finally goes like this. Okay, so this is how the wires, 1 meter length wire is taken and just wound around like this, just to save the space. So in our lab we have this kind of potentiometers which are 4000, but 5000, 10,000 even more accurate. So that time it will have 10 strips of 10 strings of wire like this, wound in this way 10 times. So here I'll show you the picture of the potentiometer what we have after this video.